is defined as fx square y, which is differentiable at xy belongs to R, and xy belongs to R2, and f dash xy, and we will find that derivative of fxy. So to do this, we will divide these functions in three parts as a combination of three linear function, and then we'll solve it. So let's define three operator. Solution. So define three operator here. L1 from R2 to R defined by define as L1 xy is equal x, and then we define L2 from R2 to R define as L2 xy. This is again x. Using chain rule, we will prove that this function f from R2 to R is and then L3 from R2 to R defined as L3 xy is equal y. F is equal L1 multiply L2 multiply L3. So we are going to use this product rule to find the derivative of this function. Now L1, L2, L3 are linear functions from R2 to R, and they are differentiable. So this implies f being the product of three differentiable function, it is differentiable. Okay, so we got the conditions for the differentiability. Now what will be the differentiation of these three functions? So now for that h is equal h1 h2 belongs to R2. Then since L1 is linear, so we'll have here L1 dash xy operating on h is equal L1h is equal h1. By similar way, L2 dash xy operating on h is equal L2h is equal h1, and L3 dash xy h is equal L3h, which is equal h2. So we got the derivative of these three functions. So now we'll apply and find the derivative of f dash x y. Okay, so from now we have here, so this will gives us now, therefore f1 dash xy operating on h, this is equal L1 dash xy on H, L2 xy as it is, L3 xy as it is, plus L1 xy, L2 dash xy operating on H, L3 xy plus L1 xy, L2 xy plus L3 dash xy operating on H. So this will gives us that L1 xy, we already calculated it, which is H1. So we'll get here H1. L2 xy, which is defined as x. So L2 xy is x, and L3 xy is y, plus here L1 xy is x, L2 xy is again H1, and L3 xy is y, plus L1 is x, L2 is x, and L3 is L3H is H2. So this will gives us 2xy H1 plus x square H. Okay, this concept can be generalized further, and in the sense that we can have let's the function is maybe like this, let g x y and g, this is equal x to the power 500, y to the power 1000, z to the power 90. So you can just have the derivative in the form of the product rule, and then you can do that, because x to the power 500, so we cannot write 500 linear operator to solve this problem. So therefore generalized formula of this one, g dash x y g. So here you will see that g is from R3 to R. So therefore we can take H as H. So H belongs to R3. H is equal H1, H2, H3. So therefore this derivative will be 500 x to the power 499. Remaining will be as it is, z to the power 90 H1 plus 1000 x to the power 500 y to the power 999 and z to the power 90 H2 plus the last one is 90 x to the power 500 y to the power 1000 z to the power 89 H. So we can generalize the whole idea in this way.